Hello students, I'm putting together a video for all of you to go through an example of normalization, and actually I'll probably do several of these for you and just so that you get a feel for this concept. So what I've done is I put together a lucid chart document, and that's what you're looking at here, and I took the normalization checklist and I essentially just copied it into lucid chart. And so I've got each section of the requirements in a text block here, and then I've got the example here to start with. So what I'll do is I will develop this example here with lucid chart, and then when I get it finished, I'll take it and put it out as a PDF document and get it out on Blackboard for you all so you can actually see the finished result. But I wanted to go through the process and show you everything here so that you could see it and then just be able to look at it later. So with that, here's the example I've got, and what we have here is a initial relation that consists of a player who is made up of a name, age, position, team, and rank. Rank is actually the rank of the team itself, so rank corresponds to team. So the first thing that you have on the checklist here is the test for 1 and F, and the first thing it has here is no repeating groups. Now, it may not always be clear what a repeating group looks like, and if you don't catch repeating groups at the beginning, it's not a big deal. You can catch them later in the process. The earlier you catch them, the better, but it's not a critical thing to catch right now. That said, if I look at the example here, a repeating group would be a situation where you'd have a name, age, and a position. Let's say you got five columns here. Let's say that you had the name, age, and the position, and you would had multiple team and ranks for a name, age, and a position. So it's pretty easy to show you an example here if we had some data to look at, and this isn't really applicable to this example here, but let me just give you an example of what I'm talking about. If I had a table with data and if it looked like this, Smith John, and the order, say it was for an order and the date was 1/1/2016, and this John Smith was buying a Swiss Army knife, and the cost of the knife was $129.99, and the dude wants 2. We'll say 2. And then we see Smith again, and he also wants to purchase a knife holster. And let's say that costs $39.99, and he wants, for whatever reason, he wants 3 of those. And then let's say, now I could keep putting Smith John on here. I'm just going to tab over. Now let's say that the guy wants he wants a camouflage vest, and we'll put that here at $79.99, and for that he wants 1. Actually, since I'm putting John Smith in here multiple times, I'm just going to delete the redundant items, redundant columns. So let's just say I've got 1 order for John Smith and he's got 3 things in his order, and then the next customer comes along with something else here, and this guy wants to purchase a AR-57 assault rifle because he's gonna go after and want to kill bigger things. So his rifle costs $899.99, He wants 6 of those puppies because he's got lots to do. And he also wants, along with that, a invisible suit, so that when he gets, government goes after him, he's got a way to hide. Okay, so if I look at this, let's say I had a table that was set up this way, all right? You notice here that I've got John Smith and he ordered 3 things. The 3 things here, these items, these Swiss Army knife holster, camouflage vest, are, oh, and I totally did an epic fail on camouflage, but I'm not going to worry about that. Anyway, this would be the repeating group. This section right here, and I don't know if this will let me do this, the highlighted section, this part right here, that's the repeating group, okay? And then this one here, the second one would have a repeating group there. So when the checklist talks about repeating groups, sometimes they're easy to spot and other times they're not so easy to spot. And the bottom line is, if you can't spot them because you don't have any data to look at, because without data it's a lot more difficult because you can't see anything, you can't see any examples of what you're looking at. If all you have are the names of the columns and there's no data to kind of give you some guidance, it's easy to not catch all these repeating groups. What happens typically, if that's the case, is if you miss a repeating group, is your initial primary key will be composite. If you find repeating groups right up front and you get rid of them by moving them off to other tables, what that does is it gives you a greater chance that your initial relations will all have single field primary keys. And as you probably know by now, looking at the checklist, if you have a relation that is set up with a single field as its primary key, it's much simpler because you don't have to worry about second normal form. If you're in first, you're automatically in second, and then you just look for third. So it's more difficult when you have a composite key than it is when you have a single attribute key. And these repeating groups, the checklist having you deal with them up at the beginning, what they're trying to do is avoid or eliminate or at least reduce as much as possible the possibility of having to deal with composite keys at the beginning of the process. So in our example here with these players, right, if I was to put in data that would correspond to the current example. Now this is for a sport, and I don't know what sport it is, so I'll just assume it's say it's hockey or something like that. And we need to make some changes to the age here. Now I'm going to put for age, let's just do this. Okay, 24, and the team, let's say it's Grand Rapids Griffins, and the rank. Now, again, the rank is for the team. I don't know what they're ranked, but let's just say they're ranked 8th in the league or whatever. And so you're not going to see John Smith in here twice because there wouldn't be any need for that here unless John Smith had different positions. Now, if it was set up so that John Smith could be a forward and sometimes he could be a defenseman, then in that particular case you would have a repeating group set up. See, so it just depends on the business rules essentially that dictate whether you would have this repeating group or not. Now, normally when you do something like this, you've got a person behind it that can answer questions you might have. And this would be one of those times where you probably would want to ask the person who wanted you to do this for them. They give you this relation, they want you to normalize it. you could ask them, okay, we have a player. Can a player have more than one position, or are they stuck with one position only? And they might say, well, a player can have different positions, but when they're on a particular team, they're only going to have that one position for that team. So they may start telling you things like that. And depending on what they tell you, it's going to dictate how you set things up initially. In this particular case, we're going to assume that a player is only ever on one team, and when they're on that one team, they're always going to have one position. Just to keep it simple, we're going to say that. Now, if that's the case, then this diagram, the way I've got the data here, that wouldn't make any sense. You're only going to see John Smith in here once. And then the next one, say I put myself in here, and I think I screwed something up here. What did I do? Okay, there we are. So I'll put my age in, and then I say I've got, say my position here is goalie. Let's see what's going on here. Okay, goalie. And then I've got the same situation here. So I've got myself in and the goalie and the team. The team happens to be the same. Now you could argue, well, isn't this a repeating group over here because you've got J.R. Griffin showing up twice? Well, not necessarily. When we define a repeating group, what we're saying is the stuff on the left over here repeats, but the stuff on the right is different. Now you could, if you put the team and stuff on the other side of this, you would then have a repeating group. But because it's on the right side of the players, it's not a repeating group in the position that it's in. So depending on the order of the columns, you may or may not have repeating groups. But the bottom line is, if it's ordered in such a way that you don't see a repeating group, that's okay. You'll be able to deal with it later. If you don't see it now, or it's not structured so that you see it now, it'll all come out in the wash later on as you follow the process. So I guess I'm going through all this just to say to you, don't panic about this repeating group issue. If you don't think you see any repeating groups, that's okay. Just move forward through the process and it'll all work itself out as you go. Okay, so with that, I'm going to close this and then we'll get on with our example here. Okay, so let's get into this example now. So we're going to say here that we have no repeating groups. Okay, and the next question here says next checklist point says all fields are atomic, i.e. broken down as far as possible. Then it says create an ID field as part of the set of new attributes. So what we're saying here is this. When I look at the list of attributes here and I see something like name, that's an attribute that describes the player. And what it says is to make another field with an ID, and that's because you're going to want a primary key, and you're going to want that primary key to be numeric. And since a name is not numeric, and it's subject to change also, it's not a very good choice for a primary key. You always want your primary keys to be things that are never going to change, and you also want them to be as small as possible, which basically means that you want it to be a number, an integer specifically, and it doesn't matter what it is, which is the point, because you never want to have to change it. So player 1 is always player 1. There's never a need to change that number, because that number has no intrinsic meaning to it. It's just any old number, you pick it at random. So what I want to do then is take this and I want to modify this. So what I'm going to do is I'm going to create a player ID field, and then as part of making things atomic or broken down, I'm going to take the name and break that apart. So I'm going to have a last name first name. And I could do a middle initial, but we'll just leave it at that for this one. And notice that I'm also putting a prefix on every field. In this case, I'm using player. Now, I might want to abbreviate that later, but for now, we'll go with that. So I've got player ID, player last name, player first name, now age. Now, when you think about age, the problem with age is that it's essentially a calculated value, because age is something that's going to change every time that player's birthday comes up. So we don't want to have to go into this database and update that thing every time the birthday of the player comes along. It's a computed field, and we want to avoid computed fields, but we can't just delete it because we want to know what the player's age is. So what we really want here is their date of birth. And knowing that, we can then take today's date, take their date of birth, and we can figure out how many years they are based on that. So I'm going to change this to player, and I'll say underscore DOB. So you can do this in your assignments. You can actually make these sorts of changes because they're sensible. You know, they're improvements on the design, and that's what we're after here. Okay, so that's fair game to be able to do that. And then we have player position. Now, team isn't really it's an attribute of the player, but team can be described, it is described with this rank here. So whenever you see an attribute that has other attributes next to it that provide additional information about it, you are probably looking here at another entity. So when I see something like this, what I will typically do is I will make a surrogate key for this. So I'll make a team ID, and then I will make a team name, and then I will make a team rank, because I know that that's ultimately where I'm headed with this. So notice I stopped using player and I switched over to team, because all of these attributes all describe a team over here. Now a player belongs to a team, so I need all of them together, at least for now. But I'm gonna name these with the team prefix, knowing that eventually I'm gonna have to pull them apart. Now, again, this isn't something you have to do right now, but if you do these things now, it just makes your life easier later. And the more experience you get doing these, the more natural this will come to you, and you'll just do stuff like this automatically without even really thinking about it. Okay, so at this point now we have taken care of step 2. All fields are atomic. I can't break down any of these fields any more than I have. The name here is for a team, so there's no first and last name for that. And so I have created an ID field as part of a set of new attributes, and so I've done that. So now it says each field has a unique name, so I don't see any 2 fields with the same name in here. That's usually pretty easy. And then the fourth test, the relation has a primary key. So when I look at this list of fields here, the question I have to ask is, if I were to create multiple rows, if this were a table and I was adding rows, what field out of that list there would always be different for every row? Could be and would be different. And the first one, the player ID in this case, is sufficient to be unique because every player is only going to be in here once. And that's because every player is on one team only. Now, if I were to say, well, a player can be on multiple teams at the same time, which of course wouldn't make any sense, but if I could say a player could be on multiple teams, well then I would have had a repeating group, but ignoring that for the moment, player ID wouldn't necessarily be unique anymore, because I could have player 1 on team 1 player 1 could be on team 2. So I could have player 1 in here twice because he's on 2 different teams. But in this particular case, since a player only belongs to a single team, I can confidently say that a given player will only be in this table once. Thus, player ID will be unique, and that can be my primary key. So when I go to create my dependency diagram, I can confidently declare that as my primary key. Now I took and created a dependency diagram from another example, and I'm just going to pull this thing up here so I can use this, and actually I can really make this thing narrower, or not as tall. So what I'll do, and this is just a starting, this is something I just had from another example, so I could just use it here. I'm just going to go in and now underscores, and when you underline things and you have underscores, looks kind of funny. So if I put the underscore in here, it works, but it just doesn't look very good, as you can see. So I'm going to forego that, and I'm just going to leave them out. So I'm just going to do that. And it doesn't look too bad. It's not the greatest, but we can worry about naming things more elegantly later on. Okay, now I need a player position. Then I'm going to need, let's see, I need 3 more fields. I'm just going to put them all in right now. And Lucidchart's nice because it lets you line things. It's got really nice tools for lining things up, you know, and I can double click in a box here and quite easily do this kind of stuff. I should probably show you how I created these boxes initially here. So I will do that here in a second. So to create a box, I just take this text box over here and I just drag it over and make it small or smaller, and give it a color, which you can hit that little paint can up there and pick whatever color you want. And that's how I do that. If I want to make another one, I can just right click on it and say duplicate, and then stick the other one right next to it now. Make this thing a little bit wider because I want them to lock together nicely. And then I can duplicate it again, and so you can stack them together. And that's how I do that. I could highlight all 3, go up to my paint can, and change all 3 of their colors at once. And once I've created a set of these, I like to reuse my boxes. I don't like to have to create them every single time from scratch, which is what I did earlier. I dragged all that stuff up here so I could do that. But as far as creating lines goes, all you have to do is just take and drag the connector point in the middle of one box. Basically, you hover over it with your mouse, and when you see that red dot, you click and hold your mouse, and then you drag to the other red circle to drop it. So for example, I've hooked these 2 up. I want to do the other ones. I go like this, drag over, and drop it there. And usually what will happen is it will line them up just the way you see it there. If it doesn't you can play around with these. Each one of these lines has its own unique pathway that you can edit. But for the time being, I think we're in good shape, so I'm going to go ahead and delete that. Okay, so what I've got here, I set my player ID up as the primary key. That's why it's in red. And all these are not accurate, although right off the bat, okay, what we're doing right now is we're doing step 5, create a dependency diagram. So the first thing you do is you put all your fields out here. You put your primary key in a different color and you underline it. And then what you do is you draw a line out of the primary key to all the other attributes. And you always do this because of the fact that a primary key field or fields determines all of the other attributes. And what that means is if I could have the player ID in my table twice, and of course I can't because it's a primary key, but if I could, everything else would always match by definition. Because, right, so if I see player 20 twice, I'm always going to see all of its attributes in there twice. Now, what you need to do now to build your dependency diagram is to take a look at every field and compare it to the ones around it, and you have to answer this question. If I could see a duplicate value for that field in my table, does it guarantee that I would see a duplicate in some other attribute every single time? So in other words, if I see a player's last name twice, does that guarantee that I'll see the same ID? Well, here's the issue. If I say I've got a player name, last name of Smith. Now I could have 2 players with the last name Smith. So I really can't say that if I see Smith twice, that it's always going to give me the same player ID, because it could be 2 different players. I could have a Joe Smith and a Roger Smith. So if I see 2 last names named Smith, it doesn't guarantee that I'm going to see the first names being the same, or anything else for that matter, because they're different players. Same is true of the first name. If I see 2 Joes in there, nothing else is guaranteed to match when the Joes match, because they could be different people. When I see a date of birth, I can't guarantee anything else will match if I see 2 dates of birth the same. If I see 2 player positions that match, I can't guarantee anything else matches. Now, what about team ID? Here's a situation where I can say something. If I see the same team ID in the database table twice, or 3 or 4, whatever, how many times, if I see that team ID multiple times, I'm guaranteed to always see the same team name and team rank. So in other words, if I see team 1 and it's Grand Rapids Griffiths ranked 8, every time I see team 1 in my database, it's always going to be Grand Rapids Griffiths rank 8. When you can say yes to that question, you have a dependency. And in this particular case, the team ID, when I see him duplicate, I can guarantee the name and the rank duplicate. What that tells me is that I have a dependency. The team ID is the determinant. A determinant always points at dependence. So I take my line out and point my determinant toward my dependent. And in this case, I have 2. Now you might say, well, what about the team name? What if I see Grand Rapids Griffins twice? Wouldn't that guarantee I always see team 1? It would make sense for that to be true. However, what if you could say that you had 2 teams with the same name? There's nothing in this table that says you can't do that. It wouldn't be a very smart thing to do, and you may not want to let it happen, but there's no practical reason to say it could never happen or should never happen. So therefore, it could, and if it did, the fact of the matter is they could be 2 different teams. So if I had Grand Rapids Griffins in there twice. One could be Grand Rapids, Michigan. One could be Grand Rapids, Minnesota. It would be really stupid, but if it's even remotely possible, if there's a 0.0001% chance that it could happen, then you have to say that it's a possibility. And even though it's extremely remote, if it's possible, you have to say that we can't draw the conclusion that a team name that's duplicating is always going to give me the same ID. Because even though their names are the same, they could be two different teams. And if they're two different teams, then even if the names are the same, the ranks could be different. So it's kind of like the names. If I have two players that have the last names that match, it doesn't guarantee that the IDs will be the same or anything else. Now, practically speaking, it probably would, but if you can't say it's always a 100% guarantee, then you cannot draw those lines to connect them. So when you go through all of these fields and you check every one of them out with their neighbors, this is what you end up with. So this is my dependency diagram, and that puts me in, now I'm in first normal form. This relation, as it's written here, is in first normal form. So now I'm ready to go and test for second normal form. So what I'm going to do is I'm going to take and give myself some space here, and I'm going to take my diagram and I'm going to duplicate it and bring it down here. So now I'm going to do my test for second normal form. The condition says that the relation must be in first normal form to begin with, and it is. The next test, is the primary key a single attribute or multiple attributes? Well, the primary key is a single attribute. If the primary key of the relation is a single attribute, the relation is automatically in second normal form. You need to go no further, proceed to the 3NF test. So I'm done with my second normal form test. I'm going to come down here and I'm going to, it's not what I wanted. I want to duplicate my relation again. And I'm going to begin my 3NF test. It takes me here. Okay. Relation is in 2NF. Yes, it is. Do any transitive dependencies exist? Now, a transitive dependency exists where an attribute is determined by another non-key attribute. Here we have two attributes, team name and team rank. Because arrows are pointing to them, that tells you that they are determined by another attribute or set of attributes. In this case, they are determined by team ID, which is a single attribute, and it is a non-key attribute, which means it's team ID, which is the determinant for team name, which is a dependent, and team rank, which is a dependent. These two have a determinant of team ID. Team ID is not part of the primary key. Otherwise it would be in red, and it's not. Thus, team ID is called a non-key attribute. Now, therefore, both of these fields here are transitive dependencies, and we have to remove them. So what we do is, in the note here, if transitive dependencies exist, create a new relation for each determinant attribute. Well, we have one determinant, that's team ID. Move the dependents out of the original relation. So we're going to take our dependents, which are these two, and move them out of the original. So when I say move, that means I can delete them from the original diagram. And when I delete them, I can also delete the lines that were used to connect them to other fields. Now it says leave the determinant behind and make it a foreign key in the original relation. Now, what I also need to do here, by the way, is bring team ID down. He's the determinant, which means that he connects to these other two lines, or these other two boxes. So when you bring these boxes down, you have to bring the determinant and all of the dependents down, keep the relationships intact, and take the determinant here and make it the primary key, which means I'm going to underline it and I'm going to put it in the color that a primary key attribute is in. Then it says to leave the determinant behind and make it a foreign key in the original relation. So I go back here and make it a foreign key. Now, what I can do here is make it italics, and that's how I can indicate that it is a foreign key. Another thing you can do is you can change the color to something else as another indicator that it's a foreign key. I don't want to underline it. I put it in italics, but primary keys are underlined. Foreign keys are italicized. And since we have color here, we can also colorize them. Now it says each field must have a unique name and each relation must have a primary key. Those are both satisfied. And there are no longer any transitive dependencies. This relation here, these two dependencies are full dependencies. A full dependency means that the dependent has a determinant, and that determinant is the entire primary key. And since team ID is the determinant, and he's the only attribute that makes up the primary key, then by definition, these two dependencies are full dependencies because the determinant fully determines them. So at this point, I am in third normal form. And I can move on to my final checklist. At this point, what I want to do is take my dependency diagram and turn that into actual names for tables. So what I'll do is I'll make a text box, and I will take it and give myself some room here. Now the first relation up here, obviously it's all about a player. So I'm going to call it the player table. And it's composed of player underscore lname, player underscore, oops, I forgot the ID. Player ID, player lname, player fname, player underscore dob, player underscore position, and team ID. Now, team ID is in italics, oops, because it's a foreign key. Player ID is underlined because it's a primary key. And every one of these fields is required. So I'm going to put the entire thing in bold. Bold indicates it's required. So normally what we put the name of the table in bold, and then the attributes may or may not be in bold depending on whether or not they're optional or required. And in this case, they're all required. Now for the second one, the second relation that I have, the name I'm going to call that one obviously is team. And I have a team ID, a team name, and a team rank. make them all bold, underline team ID, and then I have no foreign keys in this relation. So at this point, I have given each table a name. No partial or transitive dependencies exist because I'm at the end here. There better not be at this point, right? All tables have a primary key. All attributes that are not foreign keys have a unique prefix, which we've done. Notice it says all attributes that are not foreign keys have a unique prefix assigned to the table they're in, which basically what we're saying is the player table, every attribute starts with the word player except the foreign key. You want your foreign key to have the same prefix as it does in its own table as a primary key. So if it's called team ID down here, you want it to match up here. And now that you've learned SQL and you remember when we did joins, you can probably appreciate why that's the case. And then it says remove computed fields. We've already taken care of that. So at this point, this is our solution. So I'll take this, oops, Control Z to undo that. I will take my two text boxes and duplicate them and bring them down here, and that will be my final solution. So I guess what I'll do is I'll put them, I guess I can put them in a box. Let's see here. I take these two and I cut them, go in here, and do a paste. Oops. Doesn't like me doing that. Well, let's just do this. I'll just put a box around and we'll call it good. So that is my solution right there. So that is the answer to this first example. So it starts up here with this relation is the start. In the end product would go from one table to two tables. This is a one-to-many relationship. A player belongs to a team can have many players. So a simple one-to-many relationship. Now in the next example, I will do something a little more complicated. But for now, this concludes the first normalization example. Thanks for watching.